Let's see. Something's going on with my audio. Give me just a moment. So I usually hear all of this stuff. Output is this. Input. Make sure I'm connected. Yeah. Okay, that seems like it's working. Let's keep going. So just give me a moment. I'm just taking attendance as I let our brothers in. Here it is. Okay. All right. So let's see. Let's see if there are any. So let me make sure I'm streaming first. The stream looks okay. Okay. So this is the top of week 3, right? So what we're going to be doing today, we're going to use today as a homework session. Um, I'm going to go through as many of the homework questions as I can, and basically what I've been doing is I've been trying to do different questions with each set of students, right? So that way, as a collective, you'll have as a collective we would have spent time talking about all the questions. I am live streaming these to my YouTube, so these sessions are on my YouTube. If you want me to go over a specific question in particular or whatever, you have to catch my attention. I'm going to go ahead and mute the audio just so I can focus. Um, but if you have a question, like raise your hand, or in the do a virtual hand raise, or type in the chat. And also, it's a good idea to make use of the Ask My Instructor on Pearson. And then we can talk about yours specifically. If you use Ask My Instructor, it'll send me a screenshot of your very question. Keep in mind, we are doing online asynchronous. So, once you get into my Zoom session, you're not required to stay. My recommendation is just use this time. Go ahead and stay and use this time. Like if you're not really paying attention, just go ahead and do your homework now. Like this is the best time. Since you're here, we're already talking about math. As you work, if you have a question, you can ask me and we can talk about it now. These are good times to get questions answered. Um, but again, you're essentially at this stage in your life, you're adults, right? So if you decide that you want to do something, then it's up to you to make sure that your stuff is in order. I'll check the chat in just a moment. I want to suppress this because that's like messing me up. But how do I? Come on, that's irritating. And it's just on that one. That's so irritating. Wow. Okay, let me check the chat. I can't get this menu to like suppress, and it's like totally distracting. Yeah, I can't think of. Oh, another announcement is that. Hang on. Come on. This one. Okay, there's that. Maybe if I click it here, just at least get it off the other screen. So I guess my laptop probably needs to be restarted because it is totally lagging. But I'm just going to kind of go with it. So the one question comes in. I don't know if we have females in this class or not. One question comes in asking, where's the homework located? So the homework's located in Blackboard. When you go to our Blackboard, as soon as you log in, it's going to be folder number 4 that says assignments, and that's where it is. You have to register for Pearson through Blackboard. and it runs about $105. And like, but if you ever take like we use the same book for College Algebra 1, College Algebra 2, and pre-calculus. So if you ever take another professor that uses the exact same book, which is a good chance if you're taking these core math classes at Morehouse, if they use the exact same book on Pearson, you don't have to purchase access again. You only have to purchase access when it's a new book, right? And so we use this book for three of our courses. Tag, I can't get that menu to go away. Oh, that's totally distracting. And I'm trying to think. Let me see if I. Okay, what if I do this? Can I reboot this? Let me see if that might do a relaunch. Yeah, relaunch anyway. This is so frustrating. Okay, that's okay. Okay, the chat looks healthy. I can't think of anything else. So what I'm going to do, I'm just going to kind of continue where I left off with my other students and just continue working homework questions. Okay. And let's hop over to Pearson. I think I let that student in, yeah. So we're going to kind of continue. So with my other students, we left off on question 6. Some students asked specific questions, so we jumped to those. So I'm just trying to fill in things that I did not do with them. I wanted to do with you all. If you wanted to see those other questions worked out, it should be in the same playlist. So once you find one, you find them all. I guess it's like Pokemon, maybe. I don't know. But and if you need a copy of like anything written, you can also find that on our Blackboard page. It's going to be folder number 8. I think it's going to call it like box folder, not Dropbox, but it's actually folder number 7 on our Blackboard page. It's going to be called box links or whatever, but it's going to be in there. Okay. So with that, let's kind of let's keep going, making our way through this homework. So right now we're on question number 6. There seems to be a question in the chat. So again, I do have the audio suppressed right now just so I can focus. Yeah, just go ahead. You can actually speak it. I turn the audio back on. Don't worry about it. Don't worry about it. Like it only becomes an issue if we rack up a whole bunch of unexcused absences. Like if you get, I'm under the impression that it's like you're allowed as many credit hours. I think this is 2 credits. So it should be 2 unexcused absences. I'll probably push it to 3, which means that I won't really make a big deal about it until that 4th unexcused absence. That's a little bit going against protocol a little bit. But that's what it was in the past, right? So I'm just giving you guys a little bit of a cushion. It's not affecting your grade. Yeah, the attendance is not factored into your grade. It only becomes an issue if we get a lot of unexcused absences. Also, let me reiterate that this. I'm going to go ahead and suppress the audio. Let me reiterate that this is. Oh, come on. Let's see, users, right? There it is. Okay, I know I got him. We are doing. I'm pausing because I'm taking attendance. I'm letting guys in. Yes, no worries. We are doing online asynchronous. So again, once you get into my Zoom, that means you've gotten your attendance credit. I think Mr. Hughes, I think we just answered your question. I'm going to go ahead and lower your hand. If you have a question, just either use the chat or something like that again. Okay, I think we're good. Yeah, we are going to do online asynchronous. So you're not obligated to stay, but my recommendation is just kind of relax. Use this time to just go ahead and work on your homework. If my presentation is like too intense, which it is for a lot of students, I would just recommend just stay present, do your homework, just relax for like 50 minutes. Even if you just meditated, but you stayed on the Zoom call, that to me would still be better, just so that you can kind of be aware of the conversation. No worries, it's all good. Okay. So yeah, today we're just doing our best to go through as many homework questions as we can. If you want me to go through any specific question, just get my attention, raise your hand, type in the chat. And also make use of the Ask My Instructor. It'll send me a screenshot of your question. That's the best. Also, I want to say next week, be ready for exam 1 on Pearson. You're only responsible for the first 3 sections. So section 1.1, 1.2, and 1.3. So that's what that exam is going to cover. hopefully by the end of the day, I can go ahead and get all of your quizzes loaded. I just need to sit down and just do it and get it loaded. And I'll give you extra time because I know I loaded them late, but they'll be short. The quizzes are like 5 questions. And it's just similar to what you can expect on the exams, right? As far as the formatting. So you can get a little bit of practice. I think there's some activity in the chat. I might be lagging out. This, hopefully you guys can hear me. I'm getting my notifications that the audio is getting through. Yeah, you just have to do the best you can. This is another reason why I do online asynchronous, because the audio can't, the connections can just be bad at anyone's control. Okay, so this question asks us, oh, it's paused. Oh, okay. Let's share. I forgot to share the screens. My bad. Let me share these screens. So you need this one and this one. Share. Okay, so you guys can see. Sorry about that. Okay, so yeah, we're gonna kind of keep going where I left off with other students. So this is question number 6. This comes from section 1.1, question 21, and we're asked to graph this equation. All right. So at this stage, you should have a sense of what kind of graph this is going to be. Notice that the highest exponent is a 1. This is in the form of y equals mx plus b. So this should just be a straight line, right? So I'm going to click the graphing tool. I'm going to click the line tool over here, and we can click the plot points, right? So we have a y-intercept. Hopefully you can see the y-intercept. We have a y-intercept of 5. So I'm going to go onto the y-axis and put my first point at 5. Then it says the slope is 3, all right? So that means we go up 3 and to the right by 1. And so we should be at 1, 8. That's the second point. So to have a line, we just need 2 points. That's how we graph lines, and I'm going to check. It should be it, okay? The chat looks good, so I'm going to go into the next question. Okay. So this one, graph by plotting points. So they gave us several values of x. So let's see. Okay, for instance, well, let's just start when x is 2. When x is 2, 6 minus 2 is what? 4. Absolute value is basically the positive distance away from 0. So the absolute value of 4 is 4. So when x is 2, y should be at 4. Let me see. I think it's this one. 2, 4, 6, 8, 10. So when x is 2, 2, 4, that's not right. It could be this one. Let's try this one. When x is 2, 2, 4, this one looks pretty good, right? When x is 3, y should be 3. So I think these are counted by 2s. I probably should make this bigger. I'm going to do 6 really quickly, and it's going to be 0, right? I'm just going to choose this one. So I kind of did it a little bit quickly, but all I'm doing is taking these x values, plugging in, and finding the corresponding y values, right? And so absolute value, which are these vertical bars, absolute value just means the positive distance away from 0, okay? We're going to check the answer. All right. So those two were quick. Graph the following equation by plotting points. Okay. So I think we talked about, this is jumping the gun a little bit, but we did at least, I know in one of my sessions we talked about, this being a squaring function, but okay, let's not go there because that's ahead of the section. So instead, we can plot these points, right? When x is -2, when x is 0, when x is 2. So what I'm going to do, I'm going to click on this graphing tool. The highest exponent is a 2, so it should be a parabola, which is a U-shaped curve. When x is -2, right? If we plug in -2, -2 times -2 is a positive 4. Then 7 minus 4 is what? 3. So when x is -2, y is 3. Right there, right? So that's 1 point. When x is 0, y is 7. Right here. Okay, we need 1 more point. When x is 2, it's going to be a similar thing as before. When x is 2, y should be what? I think we said 3. Okay, this looks good. Let me check the chat. The chat looks okay. I'm going to hit save, and I'm going to submit that. Okay. So I just plotted those points. I think we did that one. Okay. What are the x-intercepts of the graph? Okay, write the x and y-intercepts of this graph, so we need to see this graph. So basically, we're trying to identify the x and y-intercepts. So looking at this, x-intercepts are where the graph crosses the x-axis, right? So our tick marks are labeled. We can identify this as 1, 2, 3, 4, 5, 6, 7, right? So this one is what? 5 or -5, 0, and 5. So the x-intercepts are -5, 0, and 5. Let's try that. -5, 0, and 5. It says round to the nearest integer, use commas. So I think we got, just looking at the graph, -5, 0, and 5. Okay, I'm gonna hit enter. Awesome. So the y-intercepts, let me see, is that the next thing they're asking us to do? Continue. Y-intercepts, right? So if we go back to the graph, the y-intercepts, where it crosses the y-axis, if that's 7, 1, 2, 3, 4, 5, 6, 7. So 4, 0, and -4. So I'm going to do -4, 0, and 4. Okay? We got -4, 0, and 4, right? That's just concepts. Can you identify the x and y intercepts from a graph? X-intercept is where the graph crosses the x-axis. Y-intercept is where the graph crosses the y-axis. This one also asks us to find the x and y intercepts, but from the equation. So for this one, I'm going to take some notes. Let me see. I think he got attendance credit. Let me just check my roster really quickly. I think he got credit. He might. Oh yeah, he's in there. Okay. All right, I'm gonna let him in. Okay, so let me take some notes here, and then we'll hop over to the tablet. Am I showing the right thing for the people at home? Yeah. Let me take some notes. Okay. So this is question number 10. This comes from section 1.1, question 33, right? So that's called the question ID, that 1.1.33. That means if you were to go to your book and go to section 1.1 and look at question number 33, it's going to be the exact same as this one, with just different numbers. Without sketching the graph, we're asked to find, I'm just taking some notes, find the x and y intercepts. Okay, we're given the equation 6x plus 2y equals 60. Okay, that's all we need. So let's hop over to the tablet and let's show the tablet for the people at home. I don't know why it looks like that. That's kind of weird. But how can I fix that view? I don't know why that looks like that. Let's see if I do that. I don't think it's anything here. Let me disconnect and reconnect. It's kind of displaying a little bit weird. Not sure why it was looking like that. Oh no. Okay. Man, I could use some help with this. My presentations. Like, I need to make like a logo. I need an intro and an outro. I need to figure. I think I just need some more devices to get like music and stuff in here. I know I've gotten music, but I realized that it was like slowing everything down and causing a whole bunch of lag. So that's the only reason I don't have music going. I tried doing music in the background, like in the airspace, but it was picking up static and it wasn't clear. And then when I do the music directly, it like, there's people in the woods down there. That's so weird. It slows everything down. So that's the only reason I don't have music on. But anyway, so X and Y intercepts. Now, my recommendation when doing these is to do the Y intercept first. This isn't always the case, but generally I feel like the Y intercept is easier to find than the X intercept. It's not always the case, but more often than not, that's the case. So to find the Y intercept, what we do is set x equal to 0, right? So if we set x to 0 and solve, we're going to have 6 times x plus 2y equals 60. But we said we want to set x equal to 0. So if we set x to 0, notice this first term goes to 0. Come on. First term goes to 0. We get 2y equals 60. So if we have 2 times y, and we want to get the y by itself, what's the inverse operation of multiplication? Inverse operation of multiplication is division. All right? So then ultimately, we're going to finish with y equals, what is that, 30? Okay, that's the y-intercept. What I'm going to do, yeah, I just want to shrink it down some. Why does it keep changing my view? Let me see if I go like this. Okay. Yeah, I was like, okay, we're good. I don't know why it keeps zooming in. It's like it's throwing a temper tantrum, but that's what technology does. So we found the y-intercept. Let's go ahead and find the x-intercept. So similarly, if to find the y-intercept we set x to 0, then to find the x-intercept we set y to 0. Okay. So if we make our substitutions, we're going to have 6x plus 2 times y equals 60. But in this case, y is what, 0? And so this goes to 0. You know, something just dawned on me. Like, we're rapidly approaching the fall. Each season has this like feel to it. And so it's like instantly when I thought about autumn, I started thinking about like Acres by and like the headless horseman, the leaves changing color, it being cool air, pumpkins, like all the autumn stuff just like flashed across my mind in an instant. Anyway, just being distracted. So then we have 6x equals 60. So if we want to isolate the x, the inverse operation of multiplication is again division. All right, what we do to one side of the equal sign, we do to the other. So then this is going to be what? 10. All right. So let's use this to go back and answer the question and put it in the proper form that they want, right? We have all the information we need. Let me check the chat really quickly. Chat looks healthy. Let's hop over to Pearson. Let me see it's showing there. Okay. Type in integer. It doesn't say an ordered pair. So the x-intercept that we get is 10. All right. X-intercept that we get is 10. And then the y-intercept that we get was 30. Okay. Oh, that was a good stretch. Oh, okay. Let me see the time. We got a solid 20 minutes. Let's keep it moving. So we're in question number 11. All right, we're going to take some notes. I think I need to, let's take some notes here. Okay. So this is question number 11. It comes from section 1.1, question 35. Without sketching, basically find the x and y intercepts again. So find the x and y intercepts. Okay. So we have y equals x squared minus x minus 6. Okay. Let's hop over to the tablet so we can see the notes that I took, which is going to be here. Make sure, okay, they're looking good. Okay. So let's start off with the y-intercept again. I think this is one of those cases. So again, for the y-intercept, what we want to do is set x equal to 0, right? So then this is going to give us y equals x squared minus x minus 6. Notice, first thing I did was I replaced each x with a blank set of parentheses, all right? And then what goes into the blank parentheses in this case? The value 0, right? 0 squared is 0, minus 0 is still 0. So then the result here is negative 6. So this is our y-intercept. Okay, go style, like this, right? That's our y-intercept, okay? So then for the x-intercept, same thing as before. We want to set, that's not a t, I don't know what I was writing, set y equal to 0, okay? So if we set y equal to 0, this is going to give us 0 equals x squared minus x minus 6, right? So something like this, I want to give you just a moment to think to yourself, how would you solve something like this, right? What would you do? What would Jesus do? That was a joke, right? Hopefully I was able to get you to smile a little bit. Also, let me kind of pause right here for a moment. What would Jesus do? Jesus would ask for help from his disciples. I don't know. I'm just trying to keep the joke going. But anyway, in all seriousness, my recommendation, if this stuff feels overwhelming or daunting, link up with the tutors and work on this with the tutors. Like they're generally, once they're operational, if they're not already operational, they're basically just waiting for you guys to show up. All right. They're not going to come after you. They're just going to sit there and be available. My recommendation, you have a lot of support, right? We can work on questions here in class. You got your classmates, but the tutors, you've already paid them. They're actually using the money that you've supplied with your tuition. So get your money out, get your money's worth out of them, right? Don't get the money out of them. They need the money, but but get your money's worth out of them. Get the value. You've already paid them, so link up with them. Either sit down and go through my lectures, or sit down and go through the homework. But they'll, that's what they're getting paid for. Once upon a time, I had a TA, and that was like heaven for me, because anything that I wanted you guys to sit down with somebody that you're comfortable with, I was like, hey, TA, do this. It was fantastic. You had somebody else to kind of soften the blow. At least on my end, I appreciated the TAs. So, but solving something like this, we want to use factoring, right? So let's do this. The 0 comes down, the equal symbol comes down. Now we want to see, can we factor this into something of this form, where we have an x and an x here. Now, this is factoring a trinomial. If you're not comfortable factoring, there's a couple of things. One, in our Blackboard module or whatever, folder, I think it's like folder number 6, it should say handouts. I have at least 2 documents. They kind of give you, one of the documents give you an overview. Sorry, I'm drinking a smoothie and it's making me hiccup a little bit. But one of the documents gives you a summary on how to approach a factoring question. There's like 3 main categories that we generally experience or encounter in this course. So there's one that's just one sheet that kind of gives you an overview of factoring. And then the other document on our Blackboard page is like a whole chapter devoted to factoring. It comes out of when I taught like intermediate algebra for one school. I thought it was very like detailed, and it basically goes through all the scenarios that you would come across for these type of courses. I would recommend sitting down with that with the tutors and your classmates and just taking a look at that. Okay. But here, so this is factoring a trinomial. When the second sign is negative, right? That means that our 2 signs are going to be opposite. One has to be positive and one has to be negative. So that means we're going to have a plus and a minus. So that way when we multiply, we'll get a negative. Then this first sign tells you the sign of the larger number. All right. So we know that the larger number is negative. Now we're looking for 2 numbers that multiply to give us -6 and add to give us -1. Hopefully you can see those numbers by now. Those 2 numbers are going to be -3 and 2, right? Notice -3 times a +2 is -6, okay? -3 plus 2 is going to be -1, right? So 2 numbers that multiply to give us -6 and add to give us -1. These are the 2. So then at this point, we use a technique that's called the zero factor property. Zero factor property. The zero factor property says that when 2 or more things multiply to give us 0, then each thing could potentially be 0. So long story short, you set each thing to 0 and solve, right? So if we say x plus 2 equal to 0, or we say x minus 3 equal to 0. So if either one of those are 0, it's going to make everything collapse to 0, right? So if we have plus 2, the inverse operation of addition is subtraction. So we want to subtract 2 on both sides of the equal sign. And over here, the inverse operation of subtraction is addition. Okay. If we account for those changes, this goes to 0, x equals -2, or x equals 3, right? So this is for what you see here is why I suggest to do the y-intercept first, because generally it's easier to do the y-intercept first. Generally the y-intercept is just easier to do than the x-intercept. That's not always the case, but more often than not, that seems to be the case. And then we got these 2 x-intercepts, okay? So now with this information, let's hop back over to Pearson and let's answer the questions being asked. Okay, where's my family? I want my family back. Anyway, oh, it's 3:33. Okay, because it's like answer the questions. Where's my family? Was that Liam Neeson that always does that? Anyway, so our x-intercepts, we got what? -2 and 3. So let's try that. We got -2, 3. Cross our fingers. Awesome sauce. Y-intercept we got was -6. -6. Enter and wham bam. Okay. So just another thing. So again, just a brief recap, not recap, but just announcement. Next, oh no. So we can anticipate exam 1 next Wednesday. We're not done, but we can anticipate exam 1 next Wednesday. It'll be available from Wednesday, and it'll be due the following Monday at 9 a.m. You can actually work on any assignment past the due date, but there is a 10% late penalty, right? So on any assignment, honestly, if you want an A- on any assignment, just keep working it until you get a perfect score, right? The repetition will make you stronger. And also for exam 2, let's anticipate an oral exam. I want to kind of do like a scheduling thing where, you know, each person chooses a time slot, and I want exam 2 to be oral exams, right? I want to do some oral exams where basically I need to be able to see your face. And then you can like if your laptop has a camera, you can do that to show your face. Or you can like use your phone. I kind of want you to use your phone as a projector. Now, if you want to get creative, like if you have like a tablet or if you can find some way to show your screen, but I want to be able to see your face and like see what you're writing somehow. If you have, some people have like dry erase boards. I saw this video where this woman created like a see-through dry erase board, and like she basically got some like plexiglass and like put some LED lights in there, and so when she writes on it, the images light up, and she can write like normal, but it's real savvy. It's real cool. I thought it was fun. I think it would be a fun project to build. I would even be open to giving some sort of like extra credit. If like people build that and I see it and you use it, that I would be impressed. I think that would be cool. But that I just wanted to kind of mention some of those things. So exam 1 next Wednesday, open for a few days. Again, we get unlimited attempts at all assignments. You can submit all assignments past the due date with only a 10% late penalty. So if you want an A- on anything, just keep working it until you get a perfect score. Or submit it earlier. You don't have to get a perfect score to get an A. Yeah, those are the only things that I can think of. Let me check the chat really quickly. I just wanted to mention those items. Let's go on to the next one. Okay. This was good stuff. We finally got to like a rhythm, which is cool. Uh-oh. Hopefully I may have spoke too soon. Let me reboot this thing. We're going to let that be. We're going to go like this. While this is loading, let's look at this question. Without graphing, determine whether the equation has a graph that is symmetrical with respect. Oh, symmetry. X-axis symmetry, y-axis symmetry, origin symmetry, or none. Okay, cool beans. So let me open this back up and get back to where I left off. This is question number 12. Question number 12. Okay. So let's take some notes here. So this is question number 12. This comes from section 1.1, question number 41. That's not a 1. I know you can't see it yet. Hang on. 41. But I'm going to put symmetry. So I'm going to just use symmetry and put a question mark. So that we know we're trying to find symmetry for this image without graphing. I'm sorry, I got distracted by a notification. Y equals x squared plus 7. I already know what symmetry this is just by looking at it, but let's kind of work through how to use what we've talked about so far to find the symmetry. Okay. So these are the notes that I took on that question. Okay. What kind of symmetry do we have? Okay. So now for symmetry, for instance, say we want to test for x-axis symmetry. Say we want to test for x-axis symmetry. What we do is we change y to negative y and we simplify, right? So if we want to test for x-axis symmetry, change y to negative y and simplify. If we can get back to the original, it's a yes. If we can't get back to the original, then it's a no, right? So then we're going to have negative y equals x squared plus 7. So notice, if you multiply both sides by negative, we still can't get back to the original. So is there any x-axis symmetry? This would actually be a no. No, for that one. So that was x-axis. Let's do a test for y-axis symmetry, right? For y-axis symmetry, we change, I don't know what I was writing. Redo. Okay. Y-axis symmetry, we change x to negative x and simplify. Gonna want to be a little bit more cognizant of my space, so let me shrink this down. This one is done. Nope. Like this, just a little bit. Okay. I just want to move this over some. Okay. Oh no, undo. Oh, I feel I'm a little bit ashamed of what I'm about to say. It's nothing bad. It's just marketing, making other people rich. Daggone it. We only have 5 minutes left in this class. I swear the time be going so fast. But it's marketing, making other people rich. But I just want to mention it anyway. So I did watch Cruella. I actually liked it. It caught me off guard. It was better than I thought it was going to be. So like if you do have Disney Plus, just check it out. I enjoyed it. You know. Anyway, that's the long and short of all that. I'm ashamed of it because I'm marketing. I'm making somebody else rich. I'm not talking about like my videos. Like, oh, did you catch my lecture from earlier? Man, y'all need to go watch that right now. I'm marketing for somebody else, making somebody else rich, you know. So I don't know if you'd be aware of that stuff, but you know, it's okay. I just need to start making my own stuff, become a producer, and then market my own stuff. But anyway, so let's change x to negative x, okay? So we're going to say y equals, we're going to change x to negative x in just a moment. And again, we're replacing x with negative x, okay? So now negative x times negative x, double negative is positive. So then we'll get to y equals x squared plus 7. Notice this is the original. So do we have y-axis symmetry? This would actually be a yes. Yes, we have y-axis, right? Okay. Let me go ahead and do the test for origin, just so you can have a complete set of notes. So for origin symmetry, can you guess what we're going to do? Let's see. Let's do like this. So for origin symmetry, we actually let's copy, paste. Let me get rid of what I don't need, which is all of this stuff here. And I would like to, so for origin symmetry, not only do we change y to negative y, we change x to negative x. We actually do both. Delete, copy, paste. Okay, I'm shrinking down just a little bit. Okay, so for origin symmetry, we change both. I want to do this. I'm just being a little OCD because I can be, and it's okay. Okay. Change y to negative y, change x to negative x. Okay, so we do it for both, right? So we're going to do negative y equals x squared plus 7, but instead of x, we put negative x, right? So then when we simplify this, we're going to get negative y equals x squared plus 7. And then it's a similar argument as the first one. Can we get back to the original? This one's going to be a no, right? So the only symmetry that we tested positive for was y-axis symmetry. So we do have y-axis symmetry. Oh, we are just about out of time. Let's kind of hop back over to Pearson. We got y-axis symmetry. We're going to submit that and hit enter. I'm going to glance at the next question, see if I can do it. Test. Okay. This will be the last one. I'll go ahead and do this one. We essentially need to do the same thing. I think I know what this answer is, but let's write it out. I'll try to be a little bit quick because I'm trying to get you guys out of here. This is question number 13. This is question 13. This comes from section 1.1, question 45. I'm going to abbreviate it as symmetry, and put a question mark. And we have this y equals, we got negative 7x squared plus 6x to the 4, right? Let's hop over to the tablet and show the tablet for the people at home. Okay. So, similar notion. Let me just copy these headers so I'm not having to write all that. It's all the same thing. Copy, paste. Okay. So for x-axis, we changed y to negative y. So that's going to give us negative y equals, we got this negative 7x squared plus 6x to the 4. If we multiply both sides by a negative, we don't get back to the original. So do we have x-axis symmetry? This one would be a no. Okay, y-axis symmetry, we change the x to negative x, so we're going to have y equals negative 7x squared plus 6x to the 4. And in this case, the x is going to be negative x, right? So if we have negative x squared, if we have an even number of negatives, is the final result going to be positive or negative? So if we have an even number of negatives, ultimately this is going to become y equals negative 7x squared. Hopefully you were able to keep up with that. That 6 times negative x to the 4, we have an even number of negatives there. So that should become positive, or it should stay positive, 6x to the 4, right? Is this the original? This is indeed the original. So we do happen to have y-axis symmetry in this case, right? And then the last part, if we change, I'm going to write it here for right now, y to negative y, negative 7x squared plus 6x to the 4. And again, we also, not only do we change y, we also change the x. And it's a similar argument. This one just happened to work out the same, similar as the previous example. Negative 7x squared plus 6x to the 4. Is this the original? We're going to say no, right? Let me just rearrange this stuff, kind of make it more presentable. So I want to take like this. And what I want to do is from here, I'm going to just shrink this stuff down some. Make it the presentation a little bit better. Then put it back kind of like this. So we can go about there. So then what I'm going to do is this one's going to go like here. This one, and again, all the stuff that you see me writing, you'll get a copy. I'll make a copy available for you. Okay, we'll go with this, all right? Okay, so we did get y-axis, so that's just how it happened to work out. Let's hop back over to Pearson. X-axis, we got no. Y-axis, we got yes. And origin, we got no. Okay. All right, I think that's enough for one day, all right? So that's about the time that I wanted to stop. Let me go ahead and make a copy of this available. So if you go to our Blackboard page, you should be able to find a copy of not only the notes. Oh, wait, cancel. Paper, share, box. So not only will you find a copy of the work that I've been doing with you all, but you should be able to find a copy of the work with my other sessions as well, okay? Let me check the chat. If there aren't any burning questions, enjoy the rest of your day, guys. I'll see you on Wednesday, okay? Take care.